Hello, everyone. The SPO office is very excited to present our fourth presentation of the Deep Energy Retrofit Webinar Series, DOE Headquarters Energy Efficiency ECM Implementation Webinar. My name is Elizabeth Hitchman, and I'm a Management Program Analyst in the Sustainability Performance Office. We also have with us today Jennifer Hoyniak and Min Chung from DOE Headquarters located in Washington, D.C. Before we get started, we need to go over some general housekeeping. The webinar is being recorded and may be posted on DOE's website or used internally. If you do not wish to have your voice recorded, please do not speak during the call. If you do not wish to have your image recorded, please turn off your camera or participate by phone. If you speak during the call or use a video connection, you are presumed consent to recording and use of your voice or image. Please make sure that your phone is muted so we can avoid any background noises. We will have a Q&A session at the end, so please make sure you have placed your question in the chat feature, and please specify which presenter you are addressing. A copy of the presentation and a recording of the session will be available after the webinar. This is our agenda for today. First, we have our introduction. We will briefly discuss federal building requirements. What is a deep energy retrofit, in case we need just kind of a refresher on what that is. How to utilize your ESA audit to implement energy conservation measures, or ECMs, and turn them into a deep energy retrofit project. ECM implementation at DOE headquarters, which will be presented by Jennifer Hoyniak and Min Chung. ECM implementation with or without an ESPC contract. Challenges of ECM implementation within a GSA-owned space. A Q&A period, and of course, a list of resources that are available. All right, great. So let's get started. We have come to the first part of our presentation. As we've been hearing for some time, electric demand has increased dramatically over the last few years due to the rapid expansion of data centers, artificial intelligence, and electrification. Additionally, increased demand of energy supply is driving electric consumption costs to increase. An example is the demand response prices in a regional transmission organization like PGM, which is here in the Washington, D.C. area, that coordinates the movement of wholesale electricity on the East Coast. Electric costs have gone to record highs, 9 times more than just a year ago, and that's just here in this region of on the East Coast. So it's really important right now for us to find more efficient ways to reduce our electric consumption at these sites because of all the electric demands. Okay, now we've come to the second part of the presentation, federal building requirements. First, Energy Act of 2020. The Energy Act of 2020 requires federal agencies to implement within 2 years of any identified life cycle cost-effective, efficient ECMs to implement, and at least 50% of them must be under performance contracting. ESA 432. What is ESA 432? Pretty much those are energy and water efficiency audits that all DOE sites must do for covered facilities. We're actually in the process of having data go to our sustainability dashboard, and all of those measures will be put into our dashboard, which will give us an insight as to what measures are in each building on the DOE sites. The purpose is a comprehensive approach for deploying energy and water efficiency conservation measures in federal facilities and monitoring the performance of those projects. This statute applies to all federal agencies. At a minimum, agencies must designate facilities that consume 75% of the site's total energy, and this does include on-site generated renewables used as a covered and assign a facility manager to ensure compliance with these requirements. What is a deep energy retrofit? This is the third part of our presentation, a really important part. We did a webinar on this almost a year ago now, talking about what a deep energy retrofit is. But today we're actually going to tell you how to take those ECMs and turn them into an actual project. Deep energy retrofits renovate buildings to reduce site energy by at least 40%, delivering substantial greater value than quick fix solutions. These upgrades can be done once or phased over time, depending on the budget. These projects use an integrative and whole systems approach that combine bundles of ECMs. As a bundle, they can be leveraged to further reduce energy and cost. And we will go into a little more detail shortly about what a bundle is and the importance of it. Okay, great. Now we've come to the fourth part of the presentation, how to utilize your ESA audit to implement energy conservation measures into a project. So we're going to focus on these 7 key areas. The first, understand the existing building structure and systems, assess the current state of the building, understand the scope and cost of planned ECMs, reduce electricity loads and select the appropriate measures to reduce energy use, select appropriate and efficient HVAC systems, incorporate building automation systems to optimize existing equipment, and lastly, bundling of measures. So first, understand the existing building structure. Obviously, you can't know if something is efficient or not unless you've actually done some reporting, walked around the building, etc. So the first we usually do, most sites will do, is a retrocommissioning report to check to see if it's undergone any operational changes since the last building assessment. If you haven't done a report, consider having one done properly to identify your ECMs. This is really crucial because it gives you an accurate picture. If your building is not identified as a covered facility, they still have to be efficient or maintained. But what you can do, if you haven't done an ESA audit, you can at least do a physical walkthrough. There are many buildings that are mission critical. They may not be a covered facility, but you still need to do an audit to make that building more efficient, especially if it's a really large building, it's 100,000 square feet or above. If changes have occurred, examine your commissioning reports as stated above and research any opportunity for additional energy efficient standards that your building can implement. Consider performing ongoing commissioning in accordance with the federal facilities guidance. A combination of an energy audit and a building management system will monitor energy use and will provide notifications if your building is not operating effectively. Next, assess the current state of the building. Risk is probably the most important element, right, of any project investment. Knowing what the risk is. The overall objective is to create a project that has minimal risk and will make the building run at optimal performance while trying to achieve your overall cost effectiveness. That's really key, cost effectiveness. Reducing energy costs is typically the biggest driver of operational costs of a project. Do a risk assessment to confirm whether or not these changes in your mission, changes to your mission, critical physical assets are in your building. Do a visual inspection, like I mentioned earlier. Take pictures. Examine your commissioning report. That really will help you with your assessment of your ESA audit. The audit is the blueprint to what you're going to do for the future for that building. And especially now as we have return to work, we'll have a lot more occupants. So making sure that building is efficient is more important than ever. Understand the scope and the cost of the planned ECM. An approved budget maps out the most important part of the efficiency needs, obviously, because it tells you what you can afford, what you can't afford, what is doable. Create a realistic phased plan that the DOE site sustainability manager can implement over a specified period of time. include relevant stakeholders. Obviously, you want to talk to the operations manager, any engineer that has anything to do with the building. Of course, you're going to talk to your ESCO. Obviously, that's important, but have a discussion first with the DOE site stakeholders before you even get to the ESCO. Map out a timeline for the renovation period, accounting for all possible resources. This should include an appropriate time frame for the renovation that will be the least disruptive to building occupants. A scope of work that includes relevant stakeholders, materials, cost analysis, cost factors, and resources, of course, are also very important. So always remember, include those stakeholders, because if someone doesn't agree with your plan, it could really delay your plans. That's very important. So next, reduce your electricity load. That's why we're here, right? We want to select the appropriate measures to reduce the energy use. First, upgrade LED lighting. When I first started doing building energy efficiency, that's what it meant, lighting. That was what most people thought about, right? So upgrading lighting, low-hanging fruit, saves 40% of electricity. That's pretty dramatic. So check what lighting you can do. HVAC, of course, really important. Air quality, your occupants, especially a building like Forrestal, you have your radiator systems, much older technology than some of the other DOE sites across the country. But you really want to check what your HVAC is doing and figure out how you can improve it. Insulation, building envelope, really key. Air leaks, a big reason for energy costs to go up. Building envelope always needs to be evaluated. Benchmarking, comparing it to other buildings. If you have 100 buildings on a site, look at similar buildings with similar sizes, because you may be able to put those similar ECMs into all those other buildings. Pick the building, probably that's the largest, or the one that's used the most, I should say, and kind of benchmark from there. There's a lot of course, Energy Portfolio Manager is what most people use, but there are other benchmarking tools that you can use. And lastly, energy management, such as data analytics, monitoring base, ongoing. Really important. We did a webinar on that last June. We did that with Berkeley Lab and Sandia Lab. Berkeley Lab has saved over $1 million in energy and water use. Really significant, especially on the West Coast. So there are ways that you can save money and not necessarily need a lot of personnel. Your data can tell you the story so that you can save energy. Select an appropriate HVAC system. Of course, this is really important. Of course, we know this. If you're a building manager, not everyone understands what that is. So I'm just going to roughly explain what that is. Variable refrigerant flow, your heat pumps, ductless air systems, packaged HVAC. I know I come from the utility. That's a really big one. It can really save you a lot of money if you used packaged in certain types of buildings. Split systems for indoor and outdoor use. And then, of course, hybrid heat pumps. After reducing the load as much as possible, consider what HVAC system type and sizes are most appropriate to handle the drastically reduced loads. Knowing what HVAC system you need to put in a particular building is important so that you're actually saving energy and not increasing your costs. Then we have a building automation system, lighting control, sensors. It really helps with energy waste. I know in the Farsdale building where I'm located, we have light sensors all over. It really makes a huge difference, saves energy, especially if right now we don't have a lot of occupants. So it really makes a huge difference when there's less occupants in the building. Access control to specific parts of the building, HVAC controls to optimize the equipment, sensors to smart devices. After selecting the most appropriate and efficient technology, shift your focus to optimizing the control strategies. This can be done by using a BAS. This is very crucial during COVID when we had people who were not in those buildings. A lot of, I can speak, being from the utility in the past, we had customers that were still spending the same amount of money when they had no occupants. So, we really want to make sure that using a BAS can save us money when the building is not occupied at all times. Lastly, we have bundling ECM measures as key to implementation. Life cycle costs of individual measures are considered during the process to create one bundle Why? Because it'll maximize the net present value and maximize your energy savings. Those bundles will determine how you save energy in your building, and it's something that you can use for quite some time, because usually once you buy the equipment, you're kind of stuck with it, right? So make sure it's the most efficient bundle that you can do if you only have one shot to do it. Better alignment with planned equipment. An example are air handlers. Air handling units for a building or part of a retrofit are installed at the same rate over several years as to what was planned for the code compliant air handling units. If they are installed at a faster rate, the marginal cost of the units could actually be higher. So the way you put air handler units in are really important. It's the rate that you're putting them in. Tenant or occupant turnover provides an ideal time, of course, to implement ECMs. We mentioned that earlier. Implement electrical and thermal load reducing measures first. This reduces the number of problems when you install right-sized new equipment. It is important to budget for smaller expenditures over several years. This prevents you from running out of money. So if you front load all your money and then you run out, you can't fix it later, right? So phased approach, especially in the budget, is really important when you are doing these projects. During the process of bundling measures, it is important to consider long-term energy goals for a building. If certain technologies are not in the immediate budget, of course, consider these measures at a later time. You can phase out those plans within 5 to 10 years, depending on what your time frame is. A high-level plan can help illustrate how decisions can be made and impact goals down the road. Okay, great. Now we've come to the fifth part of the presentation, the part that I'm sure everybody's waiting for. This is ECM implementation at DOE headquarters. We have two guest speakers today. Our first is Jennifer Honyak, the Director of Design and Engineering at DOE headquarters. Jennifer has worked at the Department of Energy for over 10 years. She currently works as the Director for the Office of Engineering and Design at DOE headquarters in the Office of Management. In her role, Jennifer is responsible for managing a team of engineers and project managers with a project portfolio of over $150 million. She serves as the liaison with GSA, other government agencies, and DOE stakeholders on strategic programming and projects. Her office's responsibilities include executing the headquarters sustainability program, managing design and construction contracts, and providing expert technical input to operations impacting all DOE program offices located at headquarters. Jennifer holds a Master's of Business Management degree from Pennsylvania State University and has a Bachelor of Science degree in Mechanical Engineering from Bucknell University. Jennifer is a professional engineer licensed in the Commonwealth of Virginia and holds a project management professional and federal project director level 1 certifications. Our second presenter is Min Chung, who currently works as the general engineer for the Office of Engineering and Design for DOE headquarters in the Office of Management. In this role, Min serves as the sustainability program lead for the DOE headquarters building. He is responsible for developing and implementing strategies to drive sustainable practices, focusing on reducing environmental impact, ensuring compliance, and promoting sustainability across DOE headquarters building. His other responsibilities include managing design and construction contracts and providing technical expertise on electrical engineering. Min holds a Bachelor of Science degree in electrical engineering from the University of Hawaii at Manoa. He is a certified energy manager and a project management professional. Welcome, Jennifer and Min.
Thank you very much, Elizabeth, for that great introduction. And thank you everyone for joining us today to hear more about our ECM implementation at DOE headquarters. Could you go to the next slide, Elizabeth? All right, so before we get started talking about our ECMs, I just wanted to quick give an overview of our headquarters facilities for anyone who hasn't visited them or isn't aware. We have two headquarters facilities. The first is Forrestal. It's located in downtown Washington, D.C. You can see the picture of it right there on your screen. It's about 1.8 million square feet. There are 3 buildings that you see from street level, all connected with 2 levels under the ground. We say it's like an iceberg. You see what's on top, but there's a lot more beneath the surface that you don't see. We also have the Germantown facility located in Germantown, Maryland. That's about 45 minutes without traffic outside of Washington, D.C. The Germantown facility has a main building with several outbuildings. So it is a campus. It is about 750,000 square feet, the main building. It's about 1950s vintage. Forrestal is 1960s vintage building. So they do have some older technologies that are, at or beyond their end of life, which presents some opportunities as far as ECMs are concerned. Just a little bit more information. Forrestal gets its electricity from Pepco. Its heating and cooling are provided by a GSA-owned heating transmission plant a couple blocks away. And in Germantown, we generate our own heating and cooling. We have a boiler plant, generates steam for heating at Germantown, and then a chiller plant for our cooling. You'll see on the screen there, we have several projects we've done with performance contracts to implement what we'll call our official ECMs at Forrestal and Germantown. And if you want to go to the next slide, we'll start talking about our ESPC at Forrestal, or what we call our big ESPC, our NORESCO ESPC, and we call it that because NORESCO was the ESCO that we worked with to implement these energy conservation measures. This work began in 2008 when we reached out to get proposals from ESCOs, and we selected NORESCO, and everything was finally commissioned in 2012. So it was a several-year-long process. During this time, we had 10 different ESPCs that were recommended by NORESCO that we analyzed, and 5 were then selected for implementation. The first ECM was lighting upgrades. Those light upgrades were not the whole building. At that time, it was only the lights that are underneath our north building, which is called the portico. If you don't know the north building, it's kind of on stilts, and you can walk underneath it. And those lights were mercury vapor fixtures, not very energy efficient. Those were all changed to LEDs, and that was the first ECM. The second were steam traps. We included 30 steam traps and strainers. Part of the contract with NORESCO also includes a 20-year operations and maintenance piece. And as part of that, they maintain and replace these steam traps, over 80 of them in the Forrestal facility. The next ECM that was done, and there are 2, we'll call it like major ECMs that we did as part of this project or this contract. The first is ECM 3, which is the VAVs. That stands for Variable Air Volume. So prior to the implementation of this contract, the HVAC systems in Forrestal were constant volume. What that means is when they're on, and they are blowing the same amount of air, no matter if there's a need or a demand for it or not. So they were constant volume, not very energy efficient. With the variable air volume, we did is each zone gets a variable air volume box, essentially a damper that controls the airflow. We also put variable frequency drives on our supply and return fans associated with that, so we can vary the volume based on the demand. As Elizabeth mentioned earlier, you don't want to be supplying HVAC air where it's not needed or if it's not needed. So this was a way that we could regulate the building based on how much air individual zones needed and ramp up and down our systems accordingly. This impacted not just electricity, but also steam and heating, the amount of heating we were needing to provide, and chilled water for our cooling, how much cooling we need to provide. So across the board, this was a pretty big ECM to implement. We implemented over the entire building. We had over 250 VAV boxes we needed to replace all throughout the facility. And we are nearing about 300 of these with recent modifications that we've done in the building. The next ECM was ECM4, our chiller plant. So like I said, chilled water that provides our cooling is provided by a GSA plant that is a couple blocks away. Prior to this contract, this ESPC, all of our normal cooling was based on getting chilled water from GSA. That means our critical loads as well. We have certain critical loads supporting various program functions that have to run 24/7 all year round. So we were still getting chilled water from the GSA plant in the middle of the winter. And what this ECM recommended and what we implemented was to have our own on-site chiller plant to handle our 24/7 loads. So we wouldn't need to get that, chilled water from several blocks away. We could produce it on site, and it allows us to operate what we call island mode, where we can go completely off of GSA chilled water, not have to purchase it from them, and we can support all of our on-site loads, emergency loads, 24/7 loads ourselves. Not only did this add energy savings, it also provided us with some resiliency, and that we aren't as reliant on the GSA plant, even when they have, their plant is older than our building and it is growing its issues. We now have a little bit more resiliency with them having our chiller plant on site, which has been an added bonus. And finally, ECM5 water fixtures. As you can see there, this also included some low flow toilets out in Germantown. So, your performance contracts don't have to be in one building or one site. We were able to implement energy conservation measures across both of our sites with this particular one. And then you see FOHO and CDC. FOHO is our on-site gym at Forrestal, for those not familiar with the acronym. And CDC is our Child Development Center. No, it's not the Center for Disease Control. It is our Child Development Center that is on-site at Forrestal. We installed irrigation meters that allow us to go back to our water provider and actually get a reduction in our bill. So Min has the lovely job of doing that. And he'll talk to you in a second here, of going through it and making sure that we're getting that reduction on our bill every month. Did want to talk about some of the ones we did not implement, just to mention the fact that there are, when you go through these processes, there might be conservation measures that initially come up that after thorough analysis do not get implemented. So some of the ones that we didn't implement were condensate heat recovery, EMCS upgrades. And EMCS is our BAS system, our building automation system. Some computer system improvements. This one is very interesting because over time, over the past, 13, 14, 12, 13 years now, all those recommendations from that ECM have actually been implemented over time, just based on how technology has moved through our IT office and our programs and the computer, the laptops that we use and everything. So that's been very interesting to see how our heat load has dropped based on technology improvements just over time. There were 2 different solar system recommendations. Each had paybacks well over 80 years. So they were not considered. And then the final that was not implemented was replace Windows. And Min is going in a couple slides tell you more about what we're doing with Windows today. Another reminder, just because ECMs are implemented 1 year or during one ESA evaluation performance period doesn't mean that they won't be implementable in the future, which I think is very important to remember. Keep those on your list. Just because they're not cost effective or life cycle cost effective now doesn't mean that they'll be that way forever. And if you want to go to the next slide, Elizabeth. I'll turn it over to Min to talk about our lighting ESPC.
Good afternoon, everyone. So we have we did our lighting ESPC enabled at Forrestal. So before I go into this project, I want to talk about a little bit about our ESPC enable. ESPC enable is a process. It's similar to ESPC, but it's much more streamlined process to be able to, you're able to get this project completed within 6 months or so. You know how long it took us to do the Norisco ESPC, about 2 years, compared to this project. Probably it took us less than about 6 months to complete this project because we used the ESPC enable. And ESPC Enable, again, is streamlined where you can implement the like single ECMs in a smaller facilities to quickly implement energy efficiency upgrades by contracting with an ESPC contracts, and then funding the project solely through the project projected energy cost saving. So essentially, there's no upfront capital investment. So that's another benefit of doing ESPC Enable. And the program focuses on readily identifiable energy saving measures like LED lighting upgrades, basic HVAC controls, and high efficiency water fixtures. So our project at Forestall, we had LED lights installed in existing light fixtures in all areas of Forestall. I know Jennifer talked about some of the lightings in our Noresco ones, but that wasn't it wasn't capturing entire buildings. So we did another ESPC to convert over 31,000 LED lights in non-secure areas, and then that guaranteed cost saving of about $2.9 million. And the reason why I say it's non-secure area is because we couldn't do it in secure area due to some of the security concerns when we use LED lights of the Wi-Fi and stuff. And currently we're in a performance period of its performance period is 12 years, and then we're currently in 9 years project. Next slide. And then Jennifer will go over the boiler UASC at Germantown.
Yes, thanks, Min. All right. So at Germantown, we went with a UESC instead of an ESPC. It's still a performance contract. In this case, we had our boilers were about over 50 years old. They needed to be replaced. And as such, we decided to go with a performance contract to do that. We did not have the upfront capital costs to replace them. So we reached out and we contracted with Pepco to do this UESC. There are originally 18 ECMs that we looked at. Finally, 11 were selected. I believe this process began in 2015 and was commissioned in 2017, so about a 2-year process. The main, really, we call it the boiler UESC because the whole contract was to do the boilers. And we had, all these, and we did we needed to do a bundled, Elizabeth talked about bundling ECMs. In this case, we needed to bundle the ECMs on all these other energy conservation measures to get the right payback and pay down on the boilers. So all these measures combined let us get the right payback for the boilers to implement the UESC. The new boilers are fire tube boilers, natural gas fed. These were installed during the last Trump administration, very positively received. At the time, Deputy Secretary Briette, I'm sorry, he was still Deputy Secretary at the time, came and was part of our ribbon cutting. They are American made, American manufactured Hearst boilers. So we were very proud of that investment, and that we even got at time someone from the MA team got to go down to the factory and see them being made. And they are still in operation. We have 3 main boilers and then a smaller 4th summer boiler. But the ECMs allowed us to do this project in such a way that we are, Pepco paid the upfront costs, and then we are obviously paying them back with our energy savings over a 15-year period, and we are currently in year 9. So I talked about the boilers. We also did steam meters, mechanical insulation, and that's just a reminder too. There are obviously some very active systems that you can put in place, equipment replacements and things like that. But there's also some very passive things like you can do, such as mechanical insulation and building envelope items. That's our ECM 11 there. And I believe, Elizabeth also mentioned that. Some other things we did is a steam kettle replacement and refrigeration unit controls. Those both supported our cafeteria. Unfortunately, the cafeteria hasn't been open for some time, but we are looking to reopen it for anyone out in Germantown. We're looking to do that once we get everyone back into the office, which is very exciting. We had another ECM was auditorium demand controlled ventilation. For anyone who's not aware, demand control ventilation essentially looks at the readings of the air and determines based on how much CO is coming back, how many people are there, how much ventilation needs to be supplied. So in our auditorium, that's very important. It is a very large auditorium that can fit smaller groups and then larger groups. We don't want the same amount of air being supplied if it's a smaller group versus a larger group. So this really allows the air to control based on the size of the group that is in the auditorium, and the auditorium is a separate building. So it's on a completely separate HVAC system than our main building. We also had air handling unit retro-commissioning deficiencies repair. This was based on our main building air handling unit HVAC systems. We had 3 different ECMs related to LED lighting. Like Elizabeth said, lighting's very common energy conservation measure. So we did, one for our main building, one for all the outbuildings, and then one for, as I said, it's a campus. So there's parking lights, there's street and other security systems in place that we were able to replace the lighting on. Once again, I do want to talk a little bit about ECMs that were reviewed but were not implemented at the time. So as part of this, we also looked at steam trap replacement at Germantown. Unlike Forrestal, where it was selected, it was not selected in the case of Germantown. We also looked at doing electric domestic hot water heaters. Unfortunately, this did not support or help the boiler replacement buy down aspect, so it was not selected. We had chiller plant optimization, data center optimization. This one's very interesting for us at headquarters. Our main DOE data center for our office of the OCIO, Office of the Chief Information Officer, is located at Germantown. The OCIO has the authority and jurisdiction over that space. For some time, for many, many years, it's been seen as having great capability to be a really good energy conservation measure to redo that space. At the time, they were not interested in doing that. We're now at the point where Min has a really good update in a slide where we are now looking into that energy conservation measure. So we're really excited for that one as a potential upcoming energy conservation measure. They also looked at lobby destratification fans and kitchen hood control. But once again, we selected the 11 we did based on the other 10 really being good accompaniments to the boiler replacement and paying for that overall conservation measure. Let me go to the next slide, Elizabeth.
Okay. So this one, I'm going to talk about how we can implement the ECMs with and without ESPC. So Jennifer has talked about all the ESPC we have done or ESC with the performance contract. We basically use a performance contract when capital costs were greater than available funding combined, or we can combine ECMs, and basically we use the financing portion of the ESPC contract to be able to supplement the cost to pay for the project. But then again, also at the same time, you can still do the project without a performance contract, and you can implement these ECMs with available funding, and then no financing is required. Obviously, if you do finance it, then, there's always interest that you have to pay out of pocket, and over time that's like paying a mortgage. It's better to buy upfront rather than doing a financing, because the cost of at the end the cost will actually increase more. So some of the example that we have done in our headquarter buildings, the projects that we did without a performance contract is Forrestal Solar Array. The Forrestal Solar Array, we have it installed on the north building roof. And these are actually not really energy savings per se, but these were more of a marketing, because we are in headquarter building in DC area and we're the Department of Energy. So we wanted to show the world that, the Department of Energy is promoting this, the renewable energies, and so that we can kind of showcase that to other people. And I do get a lot of tour requests from other program offices and stuff, so that we can go up there and look at this new technology. And then this was recently installed last year, 2024, and we're currently working on that. And next project is the Forrestal motion sensor lighting. We were able to do this project. It's still ongoing. What we did was we have a maintenance contract through MCOR, and during the pandemic, we weren't able to use all the work orders that we had that was allotted in the contract. So instead of just going that to the waste, we actually used that work order to have them replace these light switches to the motion sensor light switches, so that we will be able to use that to save energy on our switching. Also, we had a Germantown ultra high efficiency motors. That one, we had an opportunity to replace the motor, and then there was some rebate that we were able to use. So we used that to do that. And then Forrestal Cool Roof, the Forrestal building and Germantown is GSA owned building. So some of the projects that they actually are owner of the building and they have to execute the project. So while they're doing the roof replacement project, we have asked them to make it a cool roof, which will reduce some energy as well. So we implement it that way. And then lastly, the Forrestal main lobby revolving doors. This wasn't really done for energy saving, but we had a wind tunnel effect with the sliding doors we had. So we actually replaced it with the revolving door in order to control the climate inside the lobby area. And this ended up actually saving energy significantly. And then this actually improved the environment for the security guards and then people coming into the main lobby. Next slide, please. And Jennifer will talk about the next slides.
All right, so as Min said, we are a GSA owned, both Germantown and Forrestal are GSA owned. The operations and maintenance is delegated to the Department of Energy. That includes, obviously, our energy management, following ESA requirements. So we have a vested interest in making sure that we are saving energy, right? Plus we're DOE, so that's part of our mission to begin with. So obviously, anytime we implement one of these performance contracts, especially larger ones at our facilities, we do have to work with GSA on the implementation. We have to make sure that all the requirements of our delegation agreement with them are met. We also had to, oh, hello? I think that was a hot mic.
Yeah, please mute your mics. Thank you.
We have MOUs signed with GSA talking about the implementation of the ESPC and UESC, what notifications we need to make to GSA when, if there are any changes. So that's just some added things we have to do during our implementation and then during the management of the contract. Another piece of that is, like Min said, there's a lot of projects that GSA does for the facilities based on their mission, their look across their entire portfolio of government-owned properties. Their strategic plans for projects don't always align with ours. So it's a lot of working with them to make sure that we are aligned to the extent we can be, making sure that when they're doing projects, if there are energy saving opportunities, that we have them incorporate those. For a great example of that is the cool roof example for our north building that Min provided. Also, if there's any other projects they're doing, just making sure that they're considering energy efficiency. They are required to do that. Once again, we're the ones who sit there. We like to be the owners, feel like we're the owners, even though we're not. We have great ownership of our headquarters facilities and really push to make sure that they are pursuing their projects. And that also, obviously, when we pursue our projects, we are meeting the requirements, whether that be P100 or other delegation requirements, to make sure that all of our projects are meeting their requirements and standards. But with that, we have some really great potential upcoming energy conservation measures that we did want to talk about as well, because we are working on these, and these are some of these if you were listening earlier, you'll have noticed they were identified, over a decade ago. They weren't right at the time, but they're getting to the point where they're right now. So I'm going to let Min talk about these because Min is the one who is driving all these projects. And so I'll turn it over to you, Min.
Okay. So potential upcoming ECMs, like Jennifer mentioned, we do have upcoming project, Forrestal window upgrade project. Currently, the Forrestal building, like Jennifer said, it was 150 vintage, and all the windows are original to the building, which is single pane window. So we are trying to install secondary double pane windows inside of the building instead of replacing the entire window system with low E to improve building envelope. And what this will do is basically this will reduce the heat load into the building or the cooling and improve the building envelope so that we can reduce the HVAC energy usage. We currently have a perimeter fan coil units around the building, around the window areas. And by adding this secondary window system, then we are hoping to be able to either reduce the energy usage or to even eliminate it completely. And next project is the HVAC retro commissioning. The process of re-optimizing an HVAC system to ensure it's working efficiently and meeting the needs of building occupants. With the pandemic and then with everybody coming back to the work and everything, we know that our current HVAC system is not optimized. So by doing this HVAC retro commissioning, we're hoping to improve the current environment of the HVAC system so that people can be more comfortable, and then at the same time we can save some energy as well. And we are also looking at alternative water treatment technology to be able to, even though we're getting a city water, we do our own water treatments. So we're looking into a different method of improving our water treatments as well. And then lastly, a Germantown data center consolidation. This data center was built in 1972, and then this is the biggest energy user in Germantown building right now. And then this was actually written up as part of our ESA audits as well. So, we, with the help of CIO, who is the owner of this facility, we're trying to develop a technology, and most data moving to cloud system. CIO, we decided to consolidate footprint to a smaller footprint and then upgrade current system to reduce energy usage. So those are the upcoming projects that we're working on right now. Okay, next slide. I think that's it.
Okay, great. That was wonderful. I certainly learned a lot today. Forrestal is a huge place, so there's a lot to maintain. And it was great to see that there are so many different kinds of ECMs that can be tackled, and they don't have to be in in a year or two. They can be phased out. And Min and Jennifer have shown what you can do. And the upcoming projects with water, the revolving doors, I had no idea. That's pretty cool. It's true. It's not as cold when you first walk in, so that makes sense. So that's a great thing. So there's a lot of opportunities there that you can do in these buildings. Obviously, every building is different. It depends on where you're located, et cetera. We know that everyone's needs are different, but hopefully this has jump-started us to something that can get people, kind of food for thought. And most importantly, we want the sites to engage with Min and Jennifer for any ideas or talking, conversation about other things that can be done. So of course, we're going to have their information available. So now we have come to our Q&A. The first question we have, I guess this will be for Min, is from Heather Ottaway. Is maintenance included in the lighting cost savings?
Yes, it's really not real maintenance, but we do yearly measurement and verification by looking at 10 to 15% of the lights installed and to see if everything's working properly, and then we do the report, and by that report, that's how we make the payments to the contractor.
Okay, great. Next question is from my friend Chris Weatherly from Montgomery County Government. Do you have rough estimate cost square footage for ASHRAE level 2 audits? Do you have a cost estimate for cost square footage for ASHRAE level 2 audits?
I'd have to, yeah, I don't have that off the top of my head. I'd have to look at it. We worked with our national labs to do our audits. And
Okay.
we'd have to look at our cost per square foot we had for each of the most recent ones to see if it's an equilibrium.
Okay.
Or
Okay.
not.
Okay. All right, we'll see if we can find that out. The next question is actually for me. The recent executive orders impacting ESA audit or ECM implementation. No, ESA, as we had stated earlier in the presentation, is statute. It is law. All federal agencies are required to do ESA audits each year, or at least update into the dashboard what your ECM measures are. Those measures are not just to be put in as data, they are to be turned into projects similar to what we're doing at headquarters and other sites. So that is something that will not change. Again, it is just statute. The only ones that can turn that over is Congress. Efficiency is something that has been going on since the beginning of time. We will always want our buildings to be energy efficient, especially now, as I had mentioned earlier, with the use of more electricity. Like I said, PGM is a great example. I know I guess I'm paying attention because I live in the PGM territory, but wholesale electricity has gone through the roof. So not just residential customers, but commercial ones as well, and including, I'm sure, some federal government locations as well. So something to pay attention to. Data centers are a big deal. This administration is much into AI. I know that I will be doing a data center webinar in May to kind of talk about the importance of how much electricity data centers use. They take up not just a lot of energy, but a lot of water. So stay tuned for that. But it is something that we will always do. And then we have another question from Yusuf. Will this presentation be provided to everyone? Yes. So I will be sending out a copy of the presentation and also the recording so that everyone has the opportunity to look at it. Also, too, if you need to share it with someone that was unable to make it today. And then we have another question for Min and Jennifer. Did the ESPC or UESC projects get state or utility incentives? If so, did those go to the ESCO, DOE, or GSA?
Yes, I'll have to confirm on the ESPC and UESC. Unfortunately, I was not involved directly running those when they were implemented. So I'll check on those. I do know that we did get I believe it was utility incentive on our Germantown high efficiency motors that we did, and it went directly to DOE.
Right. Yeah. So the incentives programs is a big, I used to work on the Pepco commercial team for incentives. There are a lot of, most of you probably aren't in Maryland, but Maryland has one of the best utility incentive programs. It's called Empower Maryland. So if for some reason someone's on the call, there are a lot of incentives available, including retro commissioning. Chris Rutherly, who I mentioned earlier, was able to get huge savings for their properties in Montgomery County government. So there are a lot of opportunities there, but not just in Maryland. I'm sure there are other incentive programs across the country for our sites out west, especially. Those are things that, even if electricity is cheap, if you can get an incentive to get the cost down, it's even better because you have the opportunity of maybe expanding your project. So incentives are a great way to do that. And I think that was our last question. So to wrap this up, we do have some resources available. Last year, I put together a deep energy retrofit guide. It does talk about not just the building requirements, but the actual deep energy retrofit process, and best practices and optimal building performance. Optimal building performance is pretty much retro commissioning. So like I said before, we have a guide for that. We also have case studies. We did one for Fermi Lab located in Illinois on their ECMs that included lighting and air handlers and a bunch of other measures. That's a good one to reference. Also, the Berkeley Lab, we did a case study. We talked about, they did our webinar last year, and they also have a great case study that we put together on the $1 million savings of energy and water use, which they do every single year. Ongoing commissioning is really significant. And hopefully soon we have a monitoring-based commissioning case study coming out for Sandia National Lab that will be done, hopefully available in the summer. So analytics is really key to looking at your ECMs because it can, again, you have less people that have to monitor things because you have data to look at. So it's something that you should consider. Again, if you're interested, we also have the webinar that we recorded last year and we can talk about that. Please visit us at our Energy Hub site. It is embedded in the presentation. So when you send it, you will be able to select it. And I think that wraps us up. We are right on, we're a little bit early, which is great. But thank you all for attending today. Please contact the SPO office for any additional feedback at sustainability@hq.doe.gov. And again, thank you all. Have a wonderful afternoon. This concludes the presentation.